Good day everybody. Today we'll discuss on radical. What is a radical? How a radical is formed and the role of radical in chemistry. We have acid radical. SO4 is an acid radical. Nitrate radical NO3-. We have basic radical. Cu2+ is a basic radical. Na+ is a basic radical. K+ is a basic radical. We have another class of radical known as free radical. So in this discussion, a radical will also be known as a free radical. A free radical will also be known as a radical. A radical here is an atom which has an unpaired valence electron. Chlorine radical. There is an unpaired electron. You see here the unpaired electron is shown. A radical can be a molecule which has an unpaired valence electron. Here we have OH radical, and here the unpaired electron is shown. This is known as hydroxyl radical. The hydroxyl radical is a molecule that has one unpaired electron on the oxygen atom. One unpaired electron on the oxygen atom. These electrons, unpaired electrons, make the free radical highly chemically reactive towards other substances. Free radical plays an important role in combustion, atmospheric pollution, atmospheric chemistry, polymerization, and many other processes. In chemical equations, free radicals are frequently denoted by a dot, Cl dot, CH3 dot, placed immediately to the right of the atomic symbol or molecule. A chlorine radical, Cl dot, a methyl radical, CH3 dot. The methyl radical can be represented as shown. The electron by an arrow, half arrow. Here also you have the methyl radical tetrahedrally shown. Chlorine has formula Cl2. It is made up of two atoms of chlorine covalently bonded together. Chlorine made up of two atoms covalently bonded. The horizontal line represents 2 electrons. The 2 electrons, shared electrons, bonding electrons, in presence of light are separated. The bond is broken symmetrically. There is symmetrical breaking of the covalent bond. Each atom of chlorine takes 1 electron to form 2 chlorine radicals. The breaking of the bond is also known as cleavage of the bond. Each chlorine atom takes 1 of the 2 bonding electrons and form 2 chlorine radicals. This symmetrical breaking of the covalent bond is known as homolytic fission. Homolytic fission or homolytic cleavage. Free radicals such as Cl dot take part in radical addition or radical substitution reaction. They are reactive intermediates. Chain reactions involving free radicals can be divided into 3 steps: initiation step, propagation step, and termination step. In the initiation step, the radicals are formed. In the propagation step, the free radicals participate or involved. And in the termination step, the free radicals are destroyed or get paired to form molecule. A reaction with chlorine is known as chlorination. Chlorine reacts with methane in presence of light by free radical mechanism. Formation of free radicals is an endothermic process as it involves breaking of a covalent bond by absorption of light energy. The energy required to break this bond is known as bond dissociation energy. So the bond dissociation energy for hydrogen is 435 kilojoule and the bond energy for chlorine is 235 kilojoule. The breaking of bond can be shown using energy level diagram. You see the hydrogen molecule absorbs 435 kilojoule to form hydrogen radical. Hydrogen radicals have more energy, they are more energetic, they are more unstable, and they are more reactive. Chlorine also absorbs energy, 235 kilojoule, to form chlorine radical, which is more energetic, more reactive, more destructive. Line formula or skeletal formula can be utilized to represent free radicals. This is propyl radical, CH3, CH2, CH2 dot. It can be represented by 2 lines and a dot. The dot is the unpaired electron present in the radical. An example of a radical or monoradical is Cl dot. An example of a diradical O2 dot is oxygen diradical. The two oxygen atoms each has an unpaired electron. Free radicals are involved in causing Parkinson's disease, in causing deafness, in causing Alzheimer. It is also involved in the aging process. Getting old with time is due to free radical. So a free radical can be an atom, chlorine radical. It can be a molecule, hydroxide radical. It can be an ion, hydroxide radical. A radical is unstable. It possesses more energy. A radical has an unpaired electron. A radical is formed by homolytic cleavage of a covalent bond. A radical is formed by symmetrical breaking of the covalent bond. A radical is reactive. A radical is energetic. The chlorination of methane in presence of light takes place by a free radical mechanism, which involves initiation step, propagation step, and termination step. So I terminate here. See you next time for another lesson. Goodbye.